So for this problem, we've been given a graph of f of x, and we want to use it to answer these questions. So the first one is to find all intercepts. Intercepts are where we cross or touch either the x-axis or the y-axis. So I'm seeing 1, 2, 3, 4, 5 different points. Now I'm going to distinguish these as x and y. It's fine to list out the entire coordinates of the points. That will certainly work. It's also understood that when you're doing x-intercepts, the y values will be 0, so it's fine to just list the x values, your choice. So I've got an x value at negative 4.5, an x value at negative 2/3, x value of 2, and at 6 for my x-intercepts. For the y-intercept, there's only one, and again, it's understood that the x value will be 0 for the y-intercept, so I'll just list the y value, which is 1. Okay, the next part is to find f of negative 5. This is telling me here's the x. F of something is saying give me the y. So f of negative 5 means what's the y value when the x value is negative 5. So I just look at my points. When the x is negative 5, the y value is 1. So f of negative 5 equals 1. Okay, up next is domain. Domain is all of the x values for the entire graph, not just points that are labeled. All of the points, whether they are labeled or not, we need to know their x values. So what I like to do is I like to visualize taking this graph and moving everything on the graph straight up or straight down onto the x-axis. What would be shaded in on the x-axis? And with this one, because I'm continuing to go to the left and to the right, I've got these arrows, I'm going to cover the entire x-axis. So you could list that as just saying all reals, or if you want to put it in interval notation, that would be parentheses negative infinity to infinity to cover everything. Now range is similar from a picture, but this time we want the y values. So take the entire graph and move it straight left or right onto the y-axis. What would get shaded in? Well, again, these arrows are both going up. So that means I'm going to continue to get y values no matter how high I want to go. So my y's are going to go all the way up to infinity for my range. But what about on the bottom half? There's no arrows down here. There's definite stopping points. And if I'm moving the entire graph over, this is my lowest point on the graph. And that has a y value of negative 6. So my smallest y value for the range is negative 6. I use a bracket because I do include that value. That is a point. But then I keep on going on to infinity, which always gets a parentheses. Okay, the next part asks me to solve f of x equals negative 4. Now remember, this represents the y value. So it's saying the y is negative 4. Tell me what are the x's. So a y value of negative 4 would be right through here. There are 2 points on my graph, and only 2, because you notice if I carry this over, this part doesn't go down low enough. So there are 2 answers. X equal 3 and x equal 5. And we will be looking for you to give your answer this way. X equal, here's my numbers. We don't want coordinates of points. If I had an equation solve 2x plus 3 equals some number, I'm not going to give it a coordinate of point. I'm just going to say x equal. Same thing here. This equals negative 4. The answer is x equal 3 or 5. Okay, last parts are similar to each other. List the coordinates, so that means we want both x and y, of all of the local maximums. Local doesn't mean the absolute highest thing, it just means the highest point around there. Think of it as the top of all the hills. I see one hill here, and it has a maximum at 1, 2. So this is coordinate of the point. Here's the x and here's the y. Now the last part, we want the minimums. So those are all of the valleys. Local, smallest thing around there, not the smallest thing necessarily overall. I see 2 valleys, and they have coordinates of -3, -3, and also 4, -6.